Hello students, hope you're all fine. We have already discussed in the last class the formulas, right, for concave as well as convex lens sign conventions. Lens formula you all remember students? Yes, lens formula we are going to use, and also the sign conventions as I asked you in the last class must be learned so that you are able to understand all the numericals that we'll be taking in today's class. So this all we have already done. Now we are going to, yes, let's quickly recapitulate because all the points I won't be taking today. I've told you, I've given you ample time in between. You have got, right, to revise the formulas. So lens formula, right, this is what it is. 1 by f equals to 1 by v minus 1 by u. V, distance of image from this optical center. U, distance of object from the optical center. F is the focal length. Also, I discussed with you the magnification m, which is equal to height of image, or we can say size of image upon size of object. Correct? Let's the sign conventions for the same. Power of lens, focal length of a lens. How are the two related? I told you they are inversely proportional to each other. And if I have to define power, it is equal to 1 upon focal length, or it is the reciprocal of the focal length, where focal length is always expressed in meters and power is in diopters. Also, the sign conventions for the two I have told you, alright. These all are must. If not understood, please, before I would actually suggest you, before going with the numerical solution, do revise these all slides. That's why today I'll be sharing with you this PDF. Okay. Okay. Solution number 1. Let's start with the very first question, students. And the question is, yes, look into your books. Pay attention. The question is, at what position, the question is, at what position a candle of length 3 centimeter be placed? At what position a candle of length? Now, where the candle should be placed, that is what we are talking about. At what position a candle should be placed? Candle of length 3 centimeter. This is the height of candle given. Object 3 centimeter. Very clearly I have written. Can be placed in front of a convex lens. So very clear it is that we are talking about convex lens. So we are going to use the formulas for convex lens. No confusion over that. Okay. Convex lens. Yes. Placed in front of a convex lens so that its image of length 6 centimeter. What's the height of the image, students? 6 centimeter. So that's what we have written. Can be obtained on a screen placed at a distance of 30 centimeter behind the lens. Behind the lens, that means this is the distance of image from the lens, that is 30 centimeter behind the lens. So we need to take care of the sign conventions too. Now let's continue further. The formula for magnification, the question is asking us two things. One, yes, at what position a candle of length must be placed? This length must be placed. That is what it is, which means U. And also we are asked second part to calculate the focal length of the same. So magnification formula is size of image upon size of object. Also it is equal to V by U. Substitute the values that you know. What is the size of image? 6. Size of object 3. So 6 upon 3 equals 2. What is the distance of image from the lens? 30. And U we will work out. So it comes out. Carry out the cross multiplication. Yes. It simply comes out U as 15 centimeter. Now once I know U and V is 30 centimeter, this value, can I find out F? Which formula? Yes, it has to be the lens formula. 1 upon F equals to 1 by V minus 1 by U. Now be very clear, students, we are talking about convex lens, and for convex lens the sign conventions are to be taken care of. Okay, the focal length is positive. For convex lens, the focal length is positive. Fine. So that we will be getting at the end, but before that, let's substitute the values. Yes, image is formed behind, so it will be positive. So V is taken positive. U 15 centimeter for whatever lens I have told you, whether it is convex lens or concave lens. Image is, the object is always kept in front of lens. So U is taken negative. See, I have written it here also. It's very clear. U is taken negative. Why? Because the object is in front of lens. So minus 15. Work out the calculations. Minus minus become, minus minus will become plus. Correct, students. So We get 1 upon f equals to 1 by 30 plus 1 by 15. LCM comes out 30. 1 plus 15, 2s are 30. 1 plus 2, 1 plus 2 is 3, 3 upon 30. We get 1 upon f as 1 upon 10. Now to find out focal length, take reciprocal. Okay, take reciprocal both the sides. F comes out 10 centimeter. And what will be the sign? Plus 10 centimeter. Since it is coming positive, it verifies that your solution was all correct. Because we know for convex lens, the focal length is always positive. First is clear, student. Let's move to the next question. Yes. The second question says, yes. Second question says, a concave lens forms the image. Concave lens. Now, when I'm using the word concave lens, students, U will always be negative. V always will be negative. And F will also be negative. Right? Because we all know that a concave lens forms virtual, erect, diminished image. Perfect? So, let's start. A concave lens forms the image of an object kept at a distance of 20 centimeter. U is negative. At a distance of 10 centimeter on the side of the object. That means same side. So again, minus 10. Image is minus 10. V. U is minus 20. Clear? The question is, what is the nature of image? Yes, students. Same side if it is virtual image. Lens is convex, concave. So it will be erect and diminished. Remember this particular, I told you very clearly, this particular diminished or magnified, that is very, very important to be taken care of while deciding concave lens or convex lens. Fine. So again, I am repeating, image is formed on same side. So that is a virtual image. And lens is a concave lens. So it will be erect and diminished image. Use the lens formula. 1 upon f equals to 1 by v minus 1 by u. Put the signs. Along with the sign, 1 upon minus 10 minus 1 upon minus 20. This minus and minus becomes plus. Work out the calculations. Yes, we get 1 upon minus 10, right? And plus 1 upon 20. I've just rearranged it, nothing else. It comes out minus minus plus, so 1 upon 20 positive and this negative. 20 is the LCM. 1 minus 2 minus 1 upon 20. This is 1 upon f. So focal length will be what? Reciprocal of it. Both the sides. F comes out minus 20. Again, this minus sign which we are getting in the focal length indicates that your numerical was correct, because for concave lens, always U, V, F are negative. This was the second solution. Let's move to the next question, students. Yes. See the third question, what it says. Yes. Question number 3 is, the focal length of a convex lens. Convex lens. Focal length, it will be positive. Perfect. Focal length of a convex lens is 25 centimeters, so F is taken plus 25. At what distance from the optical center of the lens? Read this particular part, because here there are chances of you to get confused. Question says, at what distance from the optical center of the lens an object be placed? That means U is what we are asked for. Object, where is it placed? In front of the lens. So U is to be calculated to obtain a virtual image of twice the size. To obtain virtual image of twice the size means magnified image, virtual it is. So M is given plus 2. Why plus 2, clear students? Because it is twice the size. So plus 2 magnification. Put the values that you know. M magnification is equal to V upon U. Correct? So I get a relationship between V and U. Mathematically, plus 2, if the value is given, cross multiply, V is equal to 2U. Now this is the relationship between V and U. Even though value of V is not given, what can I do? At the place of V, I can place U, and hence I can work out the lens formula. Look at the screen. What's the lens formula again? 1 upon F equals to 1 by V minus 1 by U. At the place of U, let it be U in only. At the place of V, see over here, substitute 2U. Yes, 2U and U. What's the LCM? Twice U. So 1 minus 2, which comes out minus 1 upon this. And this value, focal length, was already given 25. Why am I taking positive? Yes, because it is convex lens given clearly in the question. Now take the reciprocal both the sides. I get 2u, 2 times u. What is u? The distance of object from the optical center. So twice u is equal to minus 25. So u comes out half of that. That is minus 12.5 centimeter. U is coming negative. Very clear it is. That object is placed in front of lens. For whatever lens we are talking about. Right? It is always true. So either you write u equals to minus 12.5 centimeter, or the way written in your book at the end the statement form that the object is at a distance 12.5 centimeter in front of lens. Students, here in front of lens means this negative sign. Clear? In front of lens, if I am using the word the object is placed, it indicates the negative sign only. You remember retardation acceleration in 9th class you have studied? When I say acceleration is minus 10 meter per second square, what will be the retardation value? Yes, it is 10 meter per second square because retardation represents the negative acceleration already. Same way here. Once you get this answer, the answer written in your book is also saying the same, that u is 12.5 centimeter in front of the lens. The word in front of lens means this negative sign. Clear, students? It will help you further when you will be doing the question self. Okay. Let's move to the next question and the solution. This is question number 4, numerical number 4. Okay. I've solved it for you. You can go through it. It's your homework question. If any difficulty, you can check that. Right. Now, 4th is your homework. So, let's move to the 5th one. Pay attention, students. 5th question says, an illuminated object. You all understand illuminated object that emits light, right? An object that emits light. An illuminated object lies at a distance 1 meter from a screen. Object lies at a distance 1 meter from the screen. Pay attention. Here only the students, you make mistake. Here only the chances are there to make mistake. 1 meter from screen. Object and screen. Screen is what? Where the image is formed. Distance between object and the screen means it is the total distance given 1 meter. The distance between object and the image. This total distance is given as 1 meter and 1 meter is 100 centimeter. Fine. So neither it is u nor it is v. Are you getting my point? Question number 5, students. An illuminated object lies at a distance 1 meter from screen. It means the distance between object and the screen. And screen is the place where image is formed. So basically the question is giving you the distance between object and the image formed. So this is the total value, 100 centimeter total length. Okay. Further the question says a convex lens. Convex lens. Focal length will be positive. Very good. A convex lens is used to form an image of the object on a screen placed at a distance 75 centimeter from the lens. Where is the screen placed? Where is the image formed from the lens? At a distance 75 centimeter from the lens. So this is V. What will be U? 100 minus 25, that is 25 centimeter. Now why am I taking U negative, students? Because the object is always placed in front of the lens. So I'll have to take this as negative. Clear? Screen is placed at a distance 75 centimeter from the lens. So this part is clear, students. Total distance was there, so this will be positive. So V is positive, U will be taken negative. Apply the lens formula. 1 upon F equals to, again I repeat, 1 by V minus 1 by U. V as it is 75, U minus it will become plus. 75 is the LCM, 25, 3 is up. So 1 plus 3, that is 4, 4 upon 75. F, find out the value of F, take reciprocal, it comes out 18.75 centimeter. The sign will be positive, which is coming correct here. Okay. The question is having one more part to find out the magnification. Magnification formula, we will use V upon U, or we can also use size of image upon size of object, depending upon what is given. That was not given, so M is equal to V by U. Put the value, V is positive 75, U is negative, that is 25. So solve the 2, minus 3 is the correct answer. Clear, students? 6th is homework. Still I am sharing the solution with you all. Do it self and then check it as well. Okay. Let's move to the next 7th question. A lens forms the image of an object placed at a distance 45 centimeter from it on a screen placed at a distance 90 centimeter on the other side. Pay attention, object So U is minus 45 always, whether it is concave lens or convex lens. Again, I'm repeating, object will always be placed in front of the lens. Okay, always. So it will always be negative. U straight away comes negative. Will be taken negative sign convention. Image V is positive because it is very clearly given at a distance 90 centimeter on the other side. If this is in front, it will be other side, means at behind. So that is what it is. So image V is positive. Question is asking us find the focal length. Lens formula we have. Magnification, V by U is the formula. Let's start, students. First part is name the kind of lens. See here, U is negative, V is positive. V positive, it can only be convex lens because U, V, F, all three need to be negative for concave lens. Clear, students? I have written it also as the image formed is on the other side. The image is real, hence the lens is a convex lens. With reasoning, it's all explained. No doubt it should be, and it should all be completed. Lens formula is 1 by V minus 1 by U equals to 1 by F. Put the values, minus minus again becomes plus. Okay. 90 positive, this negative, minus minus plus. LCM comes out 90, 45, 45, 2s are 1 plus 2, 3 upon 90. To find out focal length, take the reciprocal, it comes out 30 centimeter. So what is a focal length? Plus 30 centimeter because it is convex lens. And magnification V by U, put the values, 90 upon minus 45, simply minus 2 is the answer. Fine, students. This was numerical number 7. 8th is your homework. Still again I'm repeating, I'm sharing the solution so that there is no confusion. In case you get stuck somewhere, you must check and complete. Let's move to the next, that is question number 10. Question number, this last was 8. So 9 and 10 again homework. 8, 9, 10 homework. 8th I have shared with you, 9, 10 homework. Okay. See this 11 and 12 question number. Same there. So I'll take one by one. 11th question, firstly, let's see this, students. Yeah. See 11th solution. It says the power of a lens is plus 2 diopter. Positive power. The power is coming positive. When is it positive, students? Power is positive. It means the lens is convex lens. Yes. Okay. The power of a lens is plus 2 diopter. And the question is to find out the focal length and state the kind of lens. Since it's coming positive, it's convex lens. Okay, it's convex lens. And what is the formula? P equals to 1 upon F. So F equals to 1 by P. 1 upon 2 is 0.5 meter. Also, you can express it in centimeter, but standard is meter only. So you have to write it like that. Perfect. Why convex? Is it clear? Because power is positive. I've shared this also. Is there in the PDF. You can check that. Okay. Let's move to the 12th solution. Pay attention, students. Question says, express the power with sign. For convex, power is always positive. For concave, power is always negative. Express the power of lens with sign of a concave lens with focal length 20. So, 20 centimeter means 0.2 meter. 1 upon 0.2, 5 diopter. Concave lens it is. So, it will come out minus 5D. It's a concave lens, so power will come negative. Okay. So this was solution number 11 and 12. Okay. 13, please see, students. Focal length is given 25 centimeter. Okay. And it is written convex lens. So what will you take? Power. It must come positive. Take this positive. 25 centimeter means 25 upon 100. That is 0.25 meter. Power is 1 upon F. That is 1 upon 0.25. 100 upon 25. That comes out 4 diopter. And what sign? Plus 4. Clear? So this is all. You have to complete all the numericals of the lens formula till the next class, and please in the comment box share with me all the doubts that you have for the same. Okay,